So for this question, for this circuit, we want to find out the load ZL for maximum power to the load. So we know that if the load is the conjugate of the Thevenin equivalent, Thevenin impedance, then we have maximum power for the load. Okay? So that means to find out the load, we have to find out the Thevenin impedance, and also we need to calculate the maximum power to the load, and also we need to draw the equivalent Thevenin circuit and equivalent Norton circuit. All right, so to find out ZL for maximum power, first we have to find out the Thevenin impedance. Okay. So for a Thevenin equivalent circuit, first we have to use impedance blocks for each branch. So you have Z2 here, and by removing the load, we have the two terminals. So for the first step, we use a short circuit to replace the voltage source. And the Thevenin Thevenin impedance is the impedance from the two terminals. So in this case, we can see that Z1 is parallel to Z2. So that means ZTH is equal to Z1 parallel to Z2. So it's equal to Z1 times Z2 over Z1 plus Z2. And it's equivalent to, it's equal to Z1 is the total impedance of these two. So it will be 3 ohms plus J4 ohms times Z2 is here. That's the impedance for the capacitor, which is negative J6 ohms over Z1 is here, 3 ohms plus J4 ohms minus J6 ohms, which is the Z2. Okay. All right. So for the top, it's equal to after the calculation, it will be 30 ohms squared with an angle of negative 36.87 degrees. And then here the bottom is 3.61 ohms with an angle negative 33.69 degrees. And then finally we do the division. It's equal to 8.31 ohms with an angle of negative 3.18 degrees. And converting back to rectangular form is 8.3 ohms minus J 0.46 ohms. And you can see the Thevenin impedance is a combination of a resistance and a capacitive reactance. That means it's a resistor plus a capacitor. All right, so we have this Thevenin impedance. And once we find the signal impedance, we want to replace the voltage source back. And we want to find out this ETH. I mean, no, this is a E. That's E. And we want to find out the ETH here. So based on voltage divider rule, ETH can be calculated by using E times Z2 over Z1 plus Z2. So it's that's the voltage over Z2. So E over Z1 plus Z2 will be the current, and the current times Z2 will be the voltage. So, and you see V is equal to 120 volts per, the angle is 0 times Z2. Z2 is, Z2 we know is a capacitor, and for capacitor is 6 ohms with negative 90 degrees, because for capacitor the phase angle is negative 90 degrees. And this 2, we already have that, it's here. It's 3.61 ohms with an angle of negative 33.69 degrees. Okay. So if do the calculation, it's 199.45 volts. The angle is negative 56.31 degrees. So that will be the phase angle for ETH. So once we have all these values, remember the first thing we want to do is to find out the ZL for the network for maximum power to the load. Okay? So we know that if you want to deliver maximum power to the load, ZL to for to delay or max power to the load, ZL, the impedance of the load, ZL must be the conjugate of ZTH, okay? And ZTH is here. So for conjugate, we have 8.31 ohms with a positive 3.18 degrees. And convert to rectangular form, it will be 8.3 ohms minus plus J 0.46 ohms. Okay, so that will be the load that will receive maximum power from the source. Okay. So the maximum power P max will be equal to ETH squared over 4R. And for R, for this R, it should be this R. This is R. Okay? So it's not this R. It should be the R, the resistance in the load. So it is equal to ETH is here. ETH is here. 199. So it's 199.45 volts squared over 4 times R is here 8.3 ohm. So do the calculation, it will be 1.198 k watts, okay, kilowatts. So that will be the maximum power. Okay. All right. So next we want to draw the Thevenin equivalent circuit, and for Thevenin equivalent circuit, we already have ZTH. We already have ETH. Okay. So for Thevenin circuit, so the Thevenin circuit will look like this. Okay. You have ETH ZTH ZL. And remember, ZTH is this, okay? So ETH actually is equal to this, 199.45 degrees with negative 56.31 degrees, okay? So that would be ETH. And for ZTH, ZTH is here. In fact, it's a resistor with a capacitor. So, so we want to redraw this in a resistor with a capacitor. And the resistor has R has 8.3 ohms, and the capacitor, it has a XC of 0.46 ohms. Okay, so that would be the Thevenin equivalent circuit. And for Norton equivalent circuit, first you have to find out ZL and IL. And we know, so we calculate here, okay? ZN, not ZL. That's the Norton impedance. ZN is equal to ZTH. So we don't need to, because we already know the ZTH, so don't worry about that. And for IN is equal to ETH over ZTH. So ETH, we have that. It's 199.45 volts with angle of negative 56.31 degrees. And ZTH is here. It's 8.31 ohms with negative 3.18 degree. Okay, so do the division. It becomes 24 amps with negative 53.13 degrees. Okay, so that would be the Norton impedance and the Norton current. Okay, so for this Norton circuit, it will look like this. So this IN will be equal to 24A with negative 53.13 degree. Okay. Again, the Norton impedance is a combination of resistance R, which is 8.3 ohms, and XC, which is 0.46 ohms. And this will be the load.